Okay, it's your old CNC virtual machining instructor here from Suncoast Technical College in Sarasota, Florida. The CNC dude Ed here, and I'm going to do another hand programming exercise here. I used to do this in the 80s a lot, and you might have watched my other videos. So in this case right here, I would take the print and I would put all my X's and Y's for all my intersection points. So when I go to program, I could just read the X's and Y's. That'd be like trick number one, I would tell you on that. So let me just fast forward, and we have this part here, and I'm going to give you a care of Mastercam, a quick demo, right? Here's the part in isometric view, thickness, and I'm going to hit the play button. And let's see, I'm going to turn on, where is it? Stop conditions, operation change. Okay. Alrighty. First, we'd be cutting the top, creating Z0, I like to call this. Alright. Oh, yeah, it's pretty fast. Alright. Then we're going to take a 1/2" end mill and cut all the boundaries, all the contours. Here we go. Big rectangle down the bottom, and then we're going to go do the next operation, which is a little island on the top, right there. Okay. I know there's little tabs up there, but we'll deal with that later. Next, we're going to, I think, mill the slot. A little slot there. All right. I think that's 300 deep. Then we're going to start doing some hole work. We're going to spot drill. 1, 2, and 3. And then we're going to finish drill to size and depth. Speed up a little bit more. That's pretty much it. All right, let's go back to the print. We want to progress by hand, and why do we want to do that? When everybody's doing Fusion 360 and Mastercam now, right? Because many shops still do this, and as a setup man, my job was to fix problems on the shop floor. And because I had hand programmed for years, even though we were all getting CAD/CAM programs, I could fix things on the fly. And when I was in programming, I knew if I was creating good code or not, especially if we had a shop that had like 10 different machines. And you get into like things, what they call the post processor, and you got to make sure that it's producing the code you intend on. And if I even making the right selections in the CAD/CAM. So I think it's really good to learn some basics on G-code. It's like learning basics in traditional machining in order to be a better CNC machinist. You still got to know how drills work, how end mills work, all that kind of stuff. Okay, a go-to book that I use here all the time is the Haas Programming Workbook. This is the older one. There's a newer one, but they're essentially not changed. So, a very good book here. Good references. It's called the Workbook. You'd want to have this in your toolbox. And there's exercises in here, and you can download it, I believe, on the Haas website if you hunt around. It's in there. They talk about program structure, the little description of what each line means. And I used to keep like a sample program in my toolbox of different machines in my Kennedy toolbox. If I went to a machine I wasn't using that often, and it would give me right up to speed fast. Because some machines are a little bit different. I remember running a Hitachi Seiki, and it was slightly different in the beginning. See, there's a lot of reading here, sometimes I'm not big on reading, but I like pictures. And little descriptions on what each G code does, and it's also in your Haas manual that comes with the machine, which is probably on the next gen. It's probably built into the machine. Well, actually, it is, but I like these. They're good pictures. They always give you a little example of code here. I love this thing. Example of code, absolute and incremental programming. Incremental, not so popular anymore, but what an arc move is, clockwise, counterclockwise, using the R method or the I and J method. And there's more examples here. Examples. Inside, another inside, another outside. There's actually a good discussion in here, very good one. And this is like what tool length compensation is. While I'm here, I talk about it. Reference point return. This is the older way of doing it, the G28, G91, Z0. And then it says right here, another way to return a machine 0, the G53, Z0. A pocket milling, this is for quickie pockets, circular pockets. And a pocket milling exercise. And eventually here we'll get to the cutter compensation. And right here is a very good on this page 61. You notice down here it looks like a triangle. You'd have to trig out manually programming where these points are if you were to use center of the tool. Even some of these have question marks here. So the way we learned how to program is to use the print dimensions right off the print, and you tell the machine what size the tool is. So if you're using 1/2 inch end mill in your D offsets, the diameter offsets, you put in 0.500 and it'll stay away. You just have to know how to do this, the entry and exit moves and stuff like that. I just want a little shout out to Mark Terryberry, his tips of the day. He's got a nice example of essential lines in the code, which there is in the Haas workbook, but this is like beginning of a program. % sign, tool change, spindle on, first position move, height offset. I like calling this part the Gozenta part, and then you do something and then you get out of there. Gozenta, do something, get out of there. Next tool. All right, so we got that. Got the Haas workbook. We got our print. We got our part print. Where the heck did print go? Ooh. We have another thing here called Simco Editor. Oh, it's on the other screen. And here's the print. Okay. I'm going to pull up Notepad right here. I was programming something else, so I'm going to say File, New. So I'm going to write a program. Just like we saw in an example. Going to start with a % sign. That's considered to be a communication of letting the machine know that you're sending something. And then the % sign at the end of the machine says that's the end. So, and then you got to give it, I think it's the FANUC format of letter O and a bunch of digits. So letter O, and I'll go on I'll call it 5, 6, 7, 8, because I made the other one 1, 2, 3, 4. I come from the 4-digit era of code, and now that you can use 5. So I always put the name of the program up here. So I'll call this the I2L. Put my initials. I think we call this the CNC Vet. And it's going to be called Op1. So I know what that is. All right, first thing I learned was put in something called a safety line. And not so essential anymore, but you get in the habits. Oh, I'm going to leave the cap lock on because I'm hand programming and I want capital letters. You don't necessarily need to leave the spaces. But I'll do this for demonstration purposes. That's called XY plane designation. G40 is shut off any lingering counter compensations. G80 is shut off any drilling cycles, and G90 says put it into absolute positioning. You don't need to literally type in the semicolon, which is known as end of block or EOB. Just hit enter. Okay, so the next thing would be, what tools am I going to use in this? Just like I did in that demonstration. I'm going to use my 3-inch face mill. I'm going to have a 1/2-inch end mill, a little 1/4-inch end mill, and spot drill and a drill. Okay. So in this case, I'm actually going to put, I think I'll put my tool list right up here. If I put in parentheses, T1, 3.0, and I'm just going to abbreviate everything. T2.500 EM for end mill. Parentheses T3, 0.250 EM, close parentheses. T4, 0.375 spot drill, and 313. Okay, that'd be T5 is 0.313 drill. Okay, so I got my tool list. I'm going to put in setup. Setup is going to be upper left corner. So I'm going to say G54 equals X0, Y0, upper left. With a note that says shift X plus 0.05, plus, and Y negative 0.05, right? And Z0 equals top. Shift Z minus 0.01. Why are we doing it? Because, let's go back to the Mastercam demo here. I'm going to put top view and shut off the cycles. Okay, if I turn on the stock, right? This stock is about 3 inches wide, and whatever we decide to cut it to. And if you look at the front, we go to front view. We need to have machine material all the way around. So we're going to go, when we do the setup, hit fit and top. Okay. Right here is our X0, Y0 per print. We need to make sure we have machined material everywhere. So when you do your edge finder or probe on this surface and this surface, you need to shift it 50 thousandths by 50 thousandths, and that should be enough to, as long as you didn't cut the bar too short, but enough to machine all the way around this. And we need to machine the top. So when we do, if you're doing manual touch-offs, like touching off the top of this, we use a 2-inch block, or you use a gauge, or Titan uses a puck. I'm not a big fan of the paper method, but it makes sense. We're going to touch the tools off the top and shift it another 10 thousandths. Or if you're using the probe, you probe it and then shift that work offset another 10. So we have our 0 slightly embedded in the material. Okay, back to print and code. Okay. So there's my, I could pretty much set this job out without a setup sheet with just this. And I got my print. All right. And I'm going to do, let's start with a tool. Tool 1, M6. That's a tool change. And I already calculated my RPM, so I'm going to call it S2500. Get her spinning, and then go somewhere. Where am I going to go? I need to go over here somewhere to the left. And it's a 3-inch end mill, which is 1.5 radius. I'm going to add like 200 thousandths to that. So that would be X minus, let's see, 1.6 70. And where am I going to go and why? I'll go halfway. Calculator. Okay. 2.875 divided by 2 is 1.4375 minus 1.4375. Okay, I'm in position. The first 9 lines. Now we're going to go bring her down. And we are in, I should set a standard here in the beginning. Always call out your position moves and your work coordinate on every single tool change. Okay, we got rapid, absolute work position number 1, G54, and a position to go to. Got it. G43, we're going to call up the height offset for tool 1, and we're going to rapidly move to somewhere above the cutting surface. And so I'm going to go 1 inch above. I can actually identify that pretty easily if I set a tool up and they come down and they look at it. It should look like the size of a 1, 2, 3 block. Then turn the coolant on. So I'm always sticking what I'm going to do and just relate it to code. That's all the gazinta. All right, now we're going to what are we going to do? All right, I'm going to feed. This is technically called linear interpolation, but it's a line straight down. I'm going to Z0. I'm going at F50 because I'm not really cutting anything. Then I'm going to go to the right, which would be 3 inches plus that 1.7. That should be good enough. I don't need to write the G1 again because it's considered to be modal. You're in that mode. You don't have to keep on repeating it. Besides, it saves you typing, especially if you're at the machine doing this. X 1.7. But I'm going to do this at 15 inches a minute. I get to the end. Nothing else to do. I'm going to rapidly get out of there, get out of town. I'm going to go to the 1 inch where I started from, so I'm going to be repetitive and consistent. And I'm going to shut the coolant off, and I'm going to go home. I'm going to use the older way of going home, which is the G91, G28, Z0, but I'll put in parentheses the newer method is the G53, Z0. Some people use the G49. I really don't use it anymore. G49 is the opposite of G43. It removes the offset, so I may hear some comments of that, but anyway, and then we're going to say stop. We're going to do more, but I want the option of stopping. M01, a miscellaneous code. M's are miscellaneous, and you can only have 1 per line, even if they don't conflict. Just that's the rule. All right, I'm going to take a break, and we'll come on to part 2.